this circuit will be, so let's get into the, this is what the practical thing needed, but the voltage was fluctuating like this. Okay, this is the requirement, or this is the VL. This is the requirement. This is our requirement, no? Practical requirement. Output generated by rectifier. Agree this? So this was our discussion. Now, how to make it almost constant? I'll bring the Zener regulator. I'll bring the Zener regulator. So an unregulated voltage, it will regulate. Regulate means, tell me what is it, what you understand with the term first. Regulate. Regulator, fan. That I think nowadays we have a knob, no? So what is that? It's called a regulator, no? What it does? By rotating that, we can control the fan, no? And what it regulates? It regulates the flow of current through the coils inside the fan. And how much of current flow, that will determine the speed. So if I'm regulating it by controlling that knob, so it's called as a regulator. I think all of you switchboard fan nowadays, we have a small round knob, no? It'll be written 1, 2, 3, 4. By rotating that, we can control the speed. It's called like a regulator. Now this Zener diode, I'm going to use as a voltage regulator. It will regulate. How do it is? Now there's an unregulated voltage. This is RS. Zener diode symbol will be like this. Reverse ZZ, Zener diode. Are you able to see Z symbol? Ordinary diode symbols are like this. Ordinary diode symbol will be like this. Zener diode symbol will be again same thing. This is a P type. This is an N type. So whenever you see that Z symbol, no, it's a Zener diode. And Zener diode, I'll operate it in reverse bias only. So therefore, the negative type, this N type, P type, no, N type will connect it to positive terminal. This is a load. Now, what is a load? Load is something, your mobile, and this is unregulated, comes from rectifier. This I'll call Vin. Okay, what is a load? Load can be television, mobile, some music system, anything it is. This one, this is a load. This is unregulated. So unregulated, from where it is coming? Output generated by rectifier is unregulated voltage, or this is unregulated signal or output of rectifier. Have this much of background. Let's come. There are some resistance I'm bringing to protect the Zener diode from the exceeding voltages. This is one series resistor. This is RL. This will have VZ, the drop, because it is operated at breakdown. What about RZ? Time being, let's neglect it. RZ is very small. We can take it here. If RZ is small, then how this curve will, no? We're discussing some like ideal case. How it will regulate things? How it will regulate things? So this V in what happened? Definitely it will fluctuate. It will never be constant. It will be constantly fluctuating. Because of that fluctuation, what will happen if directly, if this Zener diode is now there with filter, output of rectifier with filter, everything is there. If this Zener diode is now there directly given to television, any problem in the television, the brightness will increase, decrease, the volume will increase, decrease. I think nobody will enjoy that watching such a program. Then mobile. So then same thing, like the display will increase, decrease, volume will increase, decrease, thing. Music system on its own, the volume will increase, decrease, finish over. So none of the equipments we can use this effectively. So therefore I brought the Zener diode, this one. How it will work out now? So what is the basic idea of Zener diode? I'll start with it directly with a problem. The breakdown voltage. Let me take numerical, because if I talk, no, it will become like a story, and you'll get a good sleep. So let me assume these values. VZ 10 volt, RL is 100 ohm, and the RS 200 ohm. Okay, this is having initially voltage of say like a 40 volt. The initially this let it be 40 volt. It's unregulated. What do you mean by unregulated? We'll see the meaning. Okay, these are the values we assumed it. I'll write it nearby. 200 ohm. Directly I'm coming to the explanation, so that'll be easy for you. RZ, you have to neglect it. What's a Zener diode? If it is operated at breakdown, what happened to that breakdown voltage remains constant, but current through it can increase. Will I agree this? Okay, let's write the current in various branches. This is IS. Current through Zener diode, IZ. Current through the load is IL. I think if you go for polarity, this will be plus minus, plus minus, plus minus. Sir, n-type positive. This is with respect to flow of current. Don't get confused here. With respect to flow of current, this polarity is given. Look at this one. I'm treating this just like a one resistor here. That's all. I'm treating like a resistor when I'm giving polarity here. Now, okay, what is the load? What is the requirement of load? 100 ohm is there. It is connected parallel to this. So what is the drop across the load? We'll calculate here, no? The drop across load VL is equal to VZ is 10 volt. Then what is the load current? VL by RL. VL is how much? 10. The load is 100. So this will be how much? 10 milliampere. No. So what is the power developed across the road? We write IL into VL. VL is 10 in 10 milliampere. So 100 milliwatt. What is this? This should be constant. No? These are across the load. I'll put it in some box. At any cost, what happen? These quantities should not change. Then only what happen? We'll get a constant power, means the brightness will remain constant, the volume will remain constant, everything will fine. The equipment will be much, we can enjoy that equipment. So they should not change. They should be maintained constant. So what is the comment will write?
Sir, that is 100 milliamperes.
This will be 100, huh?
Yes, sir.
Then this will be how much? 1000 milliwatt. 10 by 100, huh? Yeah, 0.100 100 milliampere. Yeah, 1000 milliampere must be constant. There's a requirement. Okay, and what is this VL? It should also be constant. VL equal to 10 volt. Will I agree this? No. So can you give guarantee that Vin will be always fixed at 40 volt? Can you give guarantee? And IS, can you give guarantee that it will be remain one fixed value? Okay, let's get into our discussion. Now IL we got it. So let's calculate IS. How much is IS here? So for that I'll write the loop equation. Vin minus ISRS minus VZ equal to 0. Okay, from here KVL. So, but Zener diode, reverse bias, some depletion layer will be there, drift current, diffusion current. You don't know anything, just write KVL. What is VZ? It's operated at breakdown. Zener diode is operated at breakdown. At breakdown, what happened to the voltage across the Zener that will remain constant. So Vin is how much? 40. This is 200. Vz is 10. 30 by 200. Anybody? How much? 150 milliampere. 150 milliampere. So there's the current that is flowing through the source, that one, and this 40 volt. Okay, now how much of current flows? Let's take how much of current through the Zener dead. Let's check it. Applying KCL, IS equal to IZ plus IL. This IL is fixed here. What is IL? IS we got 150. Okay, now finally we ended up with IZ equal to 50 milliampere. So therefore now there's a thing. There's the initial. Okay, now by chance, this Vin, what happen if it becomes 45 volt? Still what happen? The power, the current through the load and the drop across the load must remain constant. Will I agree? This will become, Vin becomes 45 volt. If it becomes 45 volt, they should not change. No, then not okay. You can say, okay, there's a good circuit. Then we will see that the current across the load and voltage across will remain constant. The Zener diode. How it is possible? Let's take into the mathematics here. So let there's the initial part. That's what we designed it. I think case one. Let Vin increase by an amount plus 5 volt. So how much Vin will become now? 45 volt. If Vin becomes 45 volt, what all changes in the circuit will come? Again, we'll calculate IS, applying the loop equation. I think I'll bring the circuit itself. It'll be easy for us to write equations. Let Vin increase by, let me rearrange one again here. Let's take this case. So what is our case now? Vin increases by an amount. So how much this will, what should I write? 45 volt I should write for this. This shall I write? 45 volt. Earlier it was 40, now 45 volt. What all changes will come in the circuit? So first we'll write the equation. And there's the first case. There's a core idea. In books, everything is there. Explanation is there, not using some values here. So I just picked up the value so that you will be comfortable. Write equation. Vin minus ISRS. So you call this Vz equals 0. So 45 is 200, Vz 10. This will be 35 by 200. Anybody value?
175 milliamperes.
175 milliampere. So the current across it now, how much it will be? 175. But what is the care? It should be 10 milliampere only, no? And this should be quote how much? 10 volt only. That's what our requirement. IL must be 10 milliampere. Sir, why you are 10 milliampere? Because earlier it was designed. Must be constant. Sir, 100 milliampere. Huh?
Yes, sir.
100 milliampere. You see the trick? Now, what will happen? IZ will increase. So how VL? Because the breakdown voltage, VL equal to VZ. VZ will be still 10 volt only. Now, if current increases here, so what will increase? IZ will increase. So let's do one thing. IS equal to IZ plus IL. Dash, I'll write it. This IZ. So this is how much? 175 milliampere. 100 milliampere. No, how much it is? 75 milliampere. So is it possible? What is a Zener diode? Current across it can increase, but voltage across it remains constant. And since the load is connected parallel to the Zener diode, the drop across the load remains constant. So how do current will remain constant? So apply Ohm's law. If the potential is 10 volt and RL is constant, current will be constant. So though voltage increase, what this Zener will do? It will see that the potential and the current across the load remains constant. But sir, current is increasing. Let it increase because that's what the Zener diode, no? Current across it can increase, but voltage across it remains constant. So how it is possible? Already we have graph. Look at here. But sir, you said some changes. But what is that changes? 0.001 volt. Okay, this is enough for me. Even the small change, let it be. So 10 point, instead of 10 point, it will become 10.001. It's no problem. But better no. If Zener diode is not there, okay, we'll agree this is a hard idea you have to digest it. What is this circuit? Though current across it increases, but voltage it will maintain constant. So that is what I'm using here. Sir, why voltage will increase? Why voltage will increase means again go back to this. If this is what required, no, 40 volt, the voltage can fluctuate. The voltage can fluctuate means here this one it will fluctuate here. So let's assume that this is what I needed. And it will fluctuate. Why it will fluctuate? Because the 240 volt will not be constant. One more big headache for the half wave rectifier, full wave rectifier, what we have now, what you say 240 volt, it will never be 240 volt. What will happen? It will become 220, sometimes will be 260, never be constant. So this particular thing will be always fluctuating, but we want a constant voltage. Half wave rectifier is unable to do anything, full wave rectifier, it is helpless. Practically what will happen is, so here, I think I'll give one still more better graph. This is the needed, and the voltage what happen will fluctuate. Like this will fluctuate. How much it will fluctuate? Not some like a plus or minus 5 volt. This will be 45, 40, 35. But what is the type of regulator we needed? We needed which will maintain constant, no? Yes. So look at this one. By Zener diode, when I brought it, no, it will see that the drop across the load and the current through the load will remain constant. Okay, let V in decrease by an amount minus 5 volt. Second case, minus 5 volt. So how much V in if it becomes 35 volt? What changes will bring in the circuit? All the values are same. You can't change Zener diode. Huh? You can't change Zener diode. You cannot change RS. So where they are inside the equipment. Over, finish. Nothing is there. IZ dash, here IZ dash. Okay, I'm taking all the symbols here. And now how much V in? V in will become 35. Okay, do calculate. Similarly, like how we proceeded, no, you do calculate here. This is V in. This what happens. This is a practical. So why the rectifier output will observe the input voltage? The input voltage at the primary that itself will fluctuate. I think all of you know 240 volts. Sometimes we say high voltage, no? 240 will become 250, 260, 280. Sometimes it'll become low voltage, high voltage, low voltage. It'll be fluctuating. No? Why that fluctuation occurs? Nobody can do anything. Everywhere, not only in India, even in America, Europe, everywhere it fluctuates. The fluctuations will be there. So maybe sometimes very high, but practically if you go say around plus or minus 15 volt fluctuation will be there all the time. It's something very bigger. Sometimes it become very high where everything will burn out, no? Bulbs, everything, TV will burn out when it becomes like a 280, 300. Sometimes they'll become dim, what happens, the bulb will not glow. But plus or minus 15 is a natural thing, any part of the world. Let's get into the, okay, do calculation. Okay, we are discussing the second part of the concept here. No? V in IS double dash RS minus VZ equals 0. Anybody value?
25.
125 milliampere. Then according to the KCL, IL I'm not changing. Look at this one. So 125 milliampere. This is 100 milliampere. You see, I think Zener diode is something very versatile device, no? Though here voltage fluctuates, it will see that the power across the load will remain constant. Agree this? So shall I say it is regulating the voltage? Also, it is regulating the line current. This is called like a line current. IL is called line current. This is called like a load voltage. It is regulating both the line current as well as load voltage. Load voltage is VL. The current passing through the load is called as IL. So what this Zener diode is doing, it will see that our television, it's like a brightness will not fluctuate. The volume will not fluctuate. The mobile, when we charge mobile, it will see that when we are charging only this problem arises. When you are using mobile, no, nothing. The battery will supply, inside the battery will supply the constant power. But when you're charging mobile and if you are weaving it, no, without Zener diode, then you can see brightness and volume will be varying. Music system you are using, on its own volume increases or decreases. Better switch off. So how to overcome this problem? Zener diode. Can we make the can we produce regulated voltage only? Because shall we at Srishalam Idle project or Ramagundam there, what we have like a power projects are there. Shall we generate a power of constant voltage? No, even you generate when you are transferring it through transformer, everything, no, the voltage will fluctuate. So for the rectifier itself, you are giving a fluctuating voltage. So the rectifier will produce fluctuating voltage. And also the rectifier is having its own problem because of filter brought some variation. So how to overcome all this? That's called like an unregulated signal or output of rectifier. I'm making everything in simplified way. How to regulate it with this one. So finally at this end, what we got? Regulated output. So this called like a voltage regulator. What is the one simplest characteristics? Current through the Zener diode though increases, but the voltage across it remains constant. What are the precautions we have to take here? We have to see that the minimum current, if you're for this circuit, so what should be the minimum current of Zener diode? 25 milliampere. It should satisfy. And what is the maximum current that is flowing in the circuit? You can see 170, how much it is? 75 milliampere. So therefore now, what type of Zener diode you have to pick up for the above situations? The Zener diode should be of. Now tell me any conditions can you put? What is the type of Zener diode we are going to pick it up? Slowly, so let's give the priority for that. What should be the minimum current? How much it is? 25 milliampere. No? Where is IZ? IZ is how much? 25 milliampere. So the Zener diode, what I pick up, if it is having some characteristics curve like this, if 25, no, let me make 20 milliampere. I'll be on safer side. Then, and what should be the VZ? VZ should be definitely 10 volt. I think problem solved. If I take a Zener diode, which is having a characteristics like this, minimum current means at when the moment breakdown occurs, what is the minimum current? I could have shown it here. Sorry, it should be here, no? So if it is having a features like this, no, I think such a Zener diode is safe for here, no? Sir, why you are putting this condition? Depending upon my requirement. So now what is the type of Zener diode you have to pick up? What is the least current is having 25 milliampere? If it is something less than that IZ minimum, safer side, no? Then what is the maximum current here? What is the current flowing? So it is around 75 milliampere. Oh, not, I think, okay, some values 50, 75, no? Okay, I made 200. I'll make it 80. Sorry. Now, if you operate the Zener diode anywhere here, I think so. If you just operate the Zener diode in this region, it can cope up. No, if you have a Zener diode where this is 40 milliampere, will it work out for this circuit? And if you have a Zener diode where this is 60 milliampere, can it really regulate here? What is the maximum Zener current? 75 milliampere. But what is the maximum current the Zener diode can permit? 60. When current more than IZ max flows, what happens to Zener diode? Will burn out. I'll give parallelly both so that you'll come to know what is the meaning of this. So what is the type of Zener diode? I think I should study the circuit here, no? What are the maximum minimums? Tell me like which Zener diode will you prefer for this particular condition? The first one or second one? What is the problem with the second one? What is the minimum current it can withstand? 40 milliamp. But what is the minimum current hour is 25 milliampere. So it cannot regulate. The second Zener diode cannot regulate. What is the maximum permitted across this Zener diode? 60 milliampere. But how much is flowing? 75 milliampere. So when you connect this second Zener diode in this circuit and when you make input voltage 45 volt, it will burn out. The Zener diode will burn out. Finish over. It will become ash. Some fog, some smoke will come out. Permanently get damaged here. So therefore, when you're using for experiment, I should calculate what are the maximum and minimum values. Keeping that in mind, I should combine this one. So for the above situation, so Zener diode 1 is more suitable. Like this IZ minimum will come. IZ max depends on what? VZ already we know. Maximum power dissipation, I'll bring it. So PZ. This should be equal to what? VZ into IZ max. So this should be equal to how much? 10 into 80 into 10 to the power of minus 3. How much it is equal to? Around 800 milliwatt, or it will become 0.8 watt. This should be the power rating of this Zener diode. This is Zener diode 1. What is the power rating of second Zener diode? This is equal to 10 volt, 60 into 10 to the power of minus 3, 0.6 watt. So which power rating? Better, I'll prefer this. If you use this, not suitable for above application. For above conditions, better you write. Above fluctuations, above delta V. Will work out successfully. Okay, got the idea why that IZ minimum, IZ max, that also will conditions will come. Okay, these are overall. This idea of that voltage regulation. I think all of you got this is like simple story, no? KCL, KVL, nothing to do. If you have any doubt, you clarify because next I'll start numerical. So got the idea? IZ max, IZ minimum, power rating, how to pick up a Zener diode. It all depends upon the fluctuation. Why the fluctuation is unwanted? Nobody can overcome that one. You can never generate a electrical signal with zero fluctuation. There'll be fluctuation. Shall I go for numericals? There's everything. Please do revise this.